So when we're talking about polynomial functions, again, we've been in standard form this whole time. The polynomial function in this form is really confusing. But basically, it's just going to follow that same pattern all the time, right? You have your x to whatever degree, your next term is going to be n minus 1. Whatever that starting degree was, minus 1, so on, all the way down, where you don't have an x term anymore, right? So they're saying this could be anything, and we have x squared, x, and then no x, right? It's just a constant. So a to the n, that very first value is called our leading coefficient.
Wasn't this not just on the quiz?
It was. I didn't spell coefficient right.
Oh, that's right. Oh, I got that right.
Okay, so the leading coefficient is the value that is on your highest degree and whatever that number is. So this is your leading coefficient, right? Well, that's like 3x squared. Whatever your highest degree, that number attached to it, that's your leading coefficient. Based off of the leading coefficient and the degree is going to determine the overall shape of our graph. Okay.
No.
So when we're talking about polynomials, we classify them by the degree and its leading coefficient. So that's what we want to do in this section. So in this case, we have 4. We just have the number 4. So its leading coefficient would be 4. It's just by itself. Its degree is 0. It's got no x value. Its degree is 0. Our next one, we have negative 5x plus 1. Its degree is, what's our exponent on 1? And then our leading coefficient is negative 5. Okay. Our next one, we've got 12x cubed minus 11x, and so on. Or 12x squared, I mean, minus 11x. Really, past that first term, we don't really care what they have. What's our degree in this case? 2. What's our leading coefficient is 12. Okay. Our third one, we have negative x cubed and some more stuff. What is our degree?
-1. Oh, wait, no,
3.
3. The next one is -1.
Correct.
Thank you.
Okay. And then we have negative 3x to the 4th. And some more things. What's our degree? 4. What's our leading coefficient?
-3.
Negative 3. And our last one, we've got 9x to the 5th plus 2x to the 4th. Again, all we really care about is that first term. What's our degree? 5. And the leading coefficient? 9. Now again, each of these degrees has a name. And so let's look at those names and what they look like on our next thing. So these are what we call our parent functions. Our parent functions identify each of these, but in the simplest form possible. So when we're talking about a constant, its parent function is just y equals some number. I would just say it's 2. Okay. So if we have y equals 2, that just means we're going to cross the y-axis at positive 2, and it's going to be a horizontal line. Okay. So that is our constant function. Our next term, or our next degree, is linear. And so our linear function is just y equals x. That is the parent function for linear. Well, if y equals x, that means for every value of x, we have that same y value. So if I plug in 0 for x, y is also 0. So we pass through the origin. At 1, I'm at 1. At negative 1, I'm at negative 1. And the line looks like that. Okay. Our third function is our quadratic. Its parent function, a degree of 2. So that means we just have x squared. Its shape is going to be U-shaped. So again, if I plug in 0 for x, I get 0 for my y. So I'm at 0, 0, the origin. If I plug in 1, well, 1 squared is 1, so I'm still on 1 on the y. Same thing with negative 1. If I plug it in, I get a negative or a positive 1. If I plug in 2, I'm going to get 4. If I plug in negative 2, I'm going to get positive 4. So this is that U shape that we've been working with. And here's where it kind of gets different things that we haven't been working with yet. So we have our cubic function. Its parent function would be y equals x cubed. Again, if I plug in 0 for my x value, 0 cubed is still 0, so y equals 0. If I plug in 1, well, 1 cubed, so 1 times 1 times 1 is going to get me a positive 1 on the y. But if I plug in negative 1 times negative 1 times negative 1, it's going to get me a negative 1. If I plug in 2 cubed is 8, so I'm going to be way up there. If I plug in negative 2, it's going to give me negative 8. So we're going to have a graph that has kind of this little S shape in it. It's got this little curve in the middle. So then let's look at our next page. We have our quartic function. That's going to be y equals x to the 4th degree. And if I was to draw the shape of it, it's going to be the same shape, but a little bit steeper than our quadratic function, right? Now, rather than going up 2 degrees, I'm going up 4 degrees. So at 0, I'm still at 0. 0 to the 4th is still 0. 1 to the 4th degree, still 1. Negative 1 to the 4th degree, still 1. But 2 to the 4th degree is 2 times 2 times 2 times 2. So rather than going up to 4, we're now going to be going up to 6. 2 times 2 gets you 4. We'll have that twice, right? So that gets us 16. So we're going to be way up high. So we have a very steep U shape in this case. And then our last one, our quintic. Its parent function is y equals x to the 5th. It is also going to be very similar to our cubic function, except now rather than going up to 8, right, when we're talking about at 2 and negative 2. Again, that first step is still just going to be 1. But now, if I have 2 to the 5th power, it's going to be 32. So it is very steep. And we're talking about that second step, right? So what does that mean? Well, what that really is saying is our quadratic functions, our quartic functions, or any even degreed function other than our constant, even though that is x to the 0, that one's kind of the one unique. They're all going to be kind of U-shaped, okay? They can be kind of W-shaped, or they might have some extra dips if you're going to like x to the 8th, x to the 10th. But their end behavior is both going to be pointing in the same direction. Our odd degree functions, notice our end behavior goes in opposite directions. So they're all going to be very similar. X to the 3rd, x to the 5th, x to the 7th, they're all going to have that same similar shape, okay, when we're talking about end behavior. So using your graphing calculator to determine the end behavior of the following functions. In fact, we don't even have to use our calculator, but we can use it to check. So if we have 4x to the fourth plus 6x cubed minus x, what do we think our end behavior is going to be if we graph that? So again, we're talking about x to the fourth. So this would be our x to the fourth. Do we have a positive or negative leading coefficient? Positive. And this is our positive parent function. So for number one, again, end behavior says as x approaches negative infinity, just meaning the left side of the equation, f of x approaches, in this case, 4x to the fourth, we're going to be going to positive infinity as well. And because it's an even degree polynomial, our left end behavior and our right end behavior are the same. They're both going to be going in that same direction, up towards infinity. And we can graph it and check. Right? If we just plug in the equation, y equals, we've got 4x to the fourth plus 6x cubed minus x. And we graph it. We were exactly right. Both my left and my right arms are going up towards infinity. Okay? If I look at number 2, I've got negative x squared plus x. What's our leading coefficient? Positive or negative? Negative. And its degree is even, right? It's 2. Well, if we're negative, that means we're going the opposite of our positive. So if our positive arms are always opening up, it means our negative arms are opening down, right? Because that negative is that vertical reflection. So that means we're going to be going down. So as x approaches negative infinity, f of x is then going to be approaching negative infinity. As x approaches positive infinity, again, it's even, so both our arms are doing the same thing. It's also going towards negative infinity. So let's graph it just to make sure. Got negative x squared plus x. If we graph it, again, we have that upside down U shape. Both of our arms are going down. Right? So let's do an odd one. So we got 2x cubed. What's our leading coefficient? Positive or negative? Positive. So what is our left end behavior going to look like then? Negative. Right? So here's our parent function. It's also positive leading coefficient, so it's going to have this shape. So our left end behavior as we go towards negative infinity, our y is also going towards that negative infinity. As x goes towards positive infinity, f of x is going towards positive infinity. Right? The way I always like to think about it and the way I remember it, if you have an even degree function, your positive is going up. Right? Opposite, if it's negative leading coefficient, it's going down. The way I remember the odd ones, your positive function, as you go to the left, you're also going down. As you go towards negative infinity on your x, your y is also going towards negative infinity. Right? It follows that pattern. As you move to the right, as you move positive, your y is also going positive. They have that match. The opposite is true when it's negative. So if it's negative, you're going to have your graph looking like this. Right? It's doing the opposite of the positive. So if we're looking at number 4, where we have negative x cubed, as x approaches negative infinity, f of x is going to approach positive infinity. Right? It's the opposite this time, because we flipped it. So that means as x approaches positive infinity, f of x is going to approach negative infinity. Okay? And our table at the bottom shows that. Right? So anytime we can kind of use this table to think about it or to answer that question for us. If we have an even degree, this is positive, negative. So even degree and it's positive, it's going to be U-shaped, opening up. Okay. If it's odd degree, positive, going to have that S shape. If it's even degree but negative, now it's going to be upside down. If it's an odd degree and negative, going to have that opposite S shape. Okay. This is true for any even or odd degree function, based off your leading coefficient being positive or negative. Those are your shapes. Okay. So with that, what is number 7? First off, is it even or odd? Even, right? Both the arms are going in the same direction. It's an even function. Is it positive or negative leading coefficient? Negative. It's upside down. What about number 8? Even or odd? Odd. Is it positive or negative? Positive. Right? We have this little S shape. Okay. So today's homework, all you have to do is 1 through 4 on 8.1. So it's just these first 4 problems. I mean, we can answer them right now. Number 1, is this going to be, or it says describe the end behavior. So as x approaches negative infinity, y approaches what? As we move to the left, we're going down, right? So it's also going to negative infinity. As we move towards positive infinity, so as x approaches positive infinity, where does f of x go? Positive infinity. B says determine whether it's an even or odd graph. Do we have an even or odd graph here?
Odd.
Odd. Is it positive or negative leading coefficient? Positive. Okay. Number 2. As we approach negative infinity, where does f of x go? So as x approaches to the left side, it also goes to negative infinity. Right? Then as x approaches positive infinity, so as we move to the right, where's our arrow point? Negative infinity. Is it an even or odd function? Even. Is it positive or negative leading coefficient?
Negative.
Negative. Number 3, describe the end behavior of the 14th degree polynomial with a positive leading coefficient. So all they're talking about is they have x to the 14th. It's a positive leading coefficient. We just put 3, it's positive. It's going to be U-shaped. Is it going to open up or down? Up. So then all you have to do is describe the end behavior. So as x approaches negative infinity, f of x approaches positive infinity. And same thing for the right behavior. And then you guys got number 4.